Assalamu alaikum. Experiment number 1. Measurement of resistance. Objective: to find the resistance of an unknown resistor from the graph of current against the potential difference across it. We know that the relation between resistance and potential difference and current is that R equals V over I. If we represent the voltage on y-axis and the current on x-axis, so here the current I in ampere, and here is the voltage in volt, the potential difference, and we plot the points V and I, we will get a straight line. That straight line must pass through the origin. The slope of this line represented the resistance. To measure that, or to draw the relation between V and I, we need many values of V and corresponding values of I. So the apparatus must contain power supply, DC power supply, and a meter must be connected in series, and the voltmeter to measure the voltage across the resistor. To get many values of V and I, we need variable resistor, okay, or rheostat. To don't leave the current on for a long time, we need a switch. The function of switch is a switch on and off immediately after we take the reading, because if we leave the current for a long time, the resistor will be heated, so the value of resistance will be not constant.
Apparatus, power supply, digital voltmeter, digital ammeter, 5 ohm resistor, switch, rheostat, variable resistor, connecting wires.
Let us study the circuit. The circuit contains the switch. I said the function of the switch is switch off and on the current. Here the current here in the circuit, denoted by I, it is the same current in that series circuit. So we can put the ammeter at any position in the circuit. The voltmeter must be connected in parallel with the resistor.
We adjusted the power supply to 4.5 volt and rheostat to the minimum value of the current. So we started in the connection as shown in the circuit opposite. So from negative to the switch. And from the switch to the power, to the rheostat. From rheostat to the resistor. And from resistor to ammeter. The ammeter connected in series. And then from ammeter to the power supply. Now we check the connection. So press on the key. Yes. So the current pass through the circuit. So it's correct. This is the series connection. Now we connect the voltmeter in parallel with the resistor. We check again. It's negative, so just we change the wire. Now it's perfect. Voltmeter working and ammeter also working. We adjust the rheostat to the minimum value of the current and take the first reading. Now the current is 0.07 and the voltage is 0.35. Change the current. So we increase the current and take another reading. 0.08, 0.37 the voltage. More current. Press on the key. 0.09 the current. 0.41 the voltage. More. 0.10 the current. 0.48 voltage. Now to be clear for you. Now another reading. The current is 0.12 and the voltage is 0.58. More current. .14 ampere, 0.6 volt.
That are the results. We plot the graph. Here, plot the graph of voltage on y-axis against or versus the current on x-axis. So the voltage here on y-axis, V in volt on y-axis. The current on x-axis in ampere. We have to start from 0. Now look at the values of the current. 0.07, 0.08, 0.09, the values are very small. To be more comfortable, when we plot the points, we multiply by 100 and divide by 100. So we can write this as 7 multiply 10 to the power negative 2. The values of potential difference is little more, so we multiply by 10 and divide by 10. So it becomes 3.5 multiply 10 power negative 1. The current, we can say 1, 2, 3, 4. So this is for the current. So the current here, it is 1. The current multiply by 10 power negative 2. So down, we write here 1. The first value, the current is 7 and 3.5. That are the points. Of course, when the voltage is 0, the current also 0. So we have this point, 0 and 0. Now we draw the line of best fit. It is line pathed in between the points. This is the line of best fit. It is a line pathed through most of the points. You know that points are more accurate because we used digital ammeter and digital voltmeter. So what is the relation between V and I? The potential difference proportional directly to the current. Use the plotted graph to determine the resistance. The resistance equals the slope. So we find the slope of this line. This is the triangle. The slope equals y2 minus y1 over x2 minus x1. So we need to get this value. So it is 5, this value here. It's 5.3. And this value here, it is 1.9. And down, this value on x-axis or in y-axis, it's 11. And this value here, it is 3.6. So this value is 3.6 on x-axis, and this value is 11. (5.3) minus 1.9. But remember, in voltage we multiply by 10 power negative 1. So we multiply this by 10 power negative 1. The current is, okay, here 11 minus 3.6. For the current, we multiply by 10 power negative 2. We find the value by using the calculator. The answer is 4.59, approximately 4.6 ohm. Compare the calculated value. This is the calculated value. It's 4.6 ohm. And the of the resistance R to the actual value. The actual value is 5 ohm. Now, to compare, we make division. So we write here 4.6 divided by 5. The answer is 0.9 approximately. It means the calculated value is less than the actual value by 0.9 times. What are the sources of error in this experiment? Why the value is not exactly equal 5? Here we have two sources of error. First one, the line of the best fit. Maybe if we take another line, the value, it will be more than this. The second, maybe we press the switch for long time, and this causes the value of resistance changes. Conclusion. In conclusion, we have to say the objective of the experiment. We have to comment on the results and what is the relation between the actual and calculated value of resistor in that experiment. Conclusion. We did this experiment to find the resistance of an unknown resistor. From what? From VI graph. We used the resistor of value 5 ohm. Our calculated value was 4.6 ohm, which approximately or nearer to the same as actual, because we used digital ammeter and digital voltmeter. It is 0.92 times less than the actual value. The calculated value of the resistor is not 5 ohm because what? Some error like line of best fit, or maybe we pressing the switch for long time. For safety, we use the small values of current because large current causes burn of the wires. I hope you understand this experiment. Thank you.